are going to solve some few questions on cbse class 10 on the chapter electricity. So I'll go for the first question, which is, in a given circuit they are asking for the power consumed in watt in the resistor 2 ohm. Okay, so first of all we have the formula P, that is equal to V into I. We can write the formula of that power in two terms, either P equal to VI or from the Ohm's law. What do we know? We know that V equal to IR. Okay. So if we put the value of V equal to IR in that equation, we will get P equal to I square R. Now my question is to you, that in this circuit which formula we will use? We will use P equal to VI or we will use P equal to I square R. We need to know that which parameter is unchanged in that question. As we know that these two resistors are in series connection, so we know that for series connection the current is unchanged. The parameter which is unchanged in the given diagram, we will use that formula. So obviously we will use P equal to I square R in this equation. Now suppose in your question it is given that the resistances are in parallel connection. At that time, in case of parallel connection, the voltage is unchanged. At that time we will go for that formula. Okay. So now draw the the equivalent resistance diagram. If you draw the equivalent resistance diagram, then this was my diagram. This is a 1 ohm resistance and 2 ohm resistance. Now what is the total equivalent resistance? Total equivalent resistance is nothing but a summation of these two resistances, as these two resistances are in series connection. So that is 1 plus 2 ohm, which is nothing but 3 ohm. So we will get 3 ohm resistance, the equivalent resistance. Now the voltage is given over here. What is the voltage? The voltage V given, that is 6 volt. Right? Then we need to find out the current. Right now we are able to find out the total equivalent resistance of the circuit, which is nothing but 3 ohm, and the supply voltage in the circuit is 6 volt. Okay. So as I already discussed, which parameter is unchanged in this diagram? The current is unchanged in the diagram, so we should use P equal to I square R, this formula. So for applying this formula, we need to find out the current. Now simple, from the Ohm's law, what we know? From Ohm's law we know that V equal to IR. Now as we are trying to find out the current for the whole circuit, so instead of R we are just denoting the resistance as R equivalent. We can write I, that is equal to V by R equivalent. Now we know the supply voltage is 6 volt, the equivalent resistance is 3 ohm, which is nothing but our 2 ampere. So our total current for the circuit, that is 2 ampere. And remember, as the circuit is in series connection, the current will not change. What is our required question? In the question they ask the power consumed in watts in the resistor of 2 ohm. So for power consumed by 2 ohm resistor, which is nothing but I square R. In I square we will write down 2 square, and our required resistance is 2 ohm. The unit should be watt. So 2 square is nothing but 4 and 2, which is nothing but 8 watt. This is our required answer. Okay, let's come to our next question. So in a question they are asking the expression related to QI, T and QVW, and among these 4 options, what is the accurate relation between them? For that we should know what is Q, what is I. Now simply Q terms as quantization. Seems a alien language, but quantization, sometimes in your book quantization termed as total charge. The number of total charge accumulated by a body, or if you say the total charge by quantization, both are same thing. Now I will explain you first of all what is quantization, and after that how current is related to the quantization. Hollow sphere. Okay, a electron come inside that sphere. Then what is the total charge of the sphere? Now just tell me that what is the charge of a single electron? The charge of a single electron, that is nothing but minus 1.6 into 10 to the power minus 19 coulomb. Okay, this is denoted by E. Now if a single electron comes inside the sphere, then what is the total charge? Total charge is nothing but Q. How many electrons are there? 1. The charge, that is E, that means 1 into minus 1.6 into 10 to the power minus 19. Now suppose there are 4 electrons, then what is the total charge? For 4 electrons, the total charge Q is nothing but number of electron into charge of that electron. Here n equal to 4 and E is nothing but minus 1.6 into 10 to the power minus 19. Okay, unit is nothing but coulomb. And you should remember this formula also. Sometimes in your questions directly they are asked question that how many electrons are there in a particular body. They will give the total number of charge, then you have to find out the total number of electrons using the formula. So now we are able to know that if there are n electrons, suppose there are n electrons, then total charge is nothing but Q equal to n. Okay, we got the formula. Now what is current? Now suppose we connect that fully or partially filled charged sphere with a electrically neutral body. Then what happened? Due to diffusion, electrons will flow from this sphere to this sphere. So this flow of electron is termed as current. the amount of electron flows with respect to time. If it is increases, then we say that the current is increasing, and if the amount of electrons are decreasing with respect to time, then we say that the current is decreasing. So from that we will give the definition of current, that I that is nothing but equal to number of charge flowing with respect to time, I equal to Q by T, and unit is coulomb per second, which is nothing but termed as ampere. Now we'll try to find out that among these four options which will fitted in my this equation. Now from there we can also write Q equal to I into T. Okay, let's check out that which option is correct. Now I equal to Q by T, this is also right. Now Q equal to IT, this is also right. Again Q equal to I by T, Q equal to I by T, this option is not right. Again I equal to Q by T, this option is also right. So we cannot get the actual answer, so we have to go for the second option, or for the second option match. Now simple, we know the definition of voltage. Voltage is nothing but total work done by total charge Q, unit is volt. So from there we can also write W, it is nothing but V into Q. Now let's match the options. W equal to V by Q, W equal to V by Q, no. So the option 1 is eliminated. Go for the next option. W equal to V into Q. Okay, this option is right. V equal to W by Q. Option C is automatically eliminated before, and Q equal to W by V. This is also eliminated. So what will be the right answer? Our right answer is option B, Q equal to IT and W equal to V into Q. Okay, let's come to the next PYQ, that is previous year question of cbse class 10. In that question, they are asking you, write the formula for determining the equivalent resistance between A and B for two conditions. So basically they are trying to ask you the formula for series connection and parallel connection, formula for equivalent resistances. So I am going to derive the equations. To derive the equation, first of all, you know that in which connection current changes and in which connection voltage remains constant, and current changes and in another connection where voltage is changing and current is constant. So first of all, you should know the concept of series connection. Now in series connection, if this is our resistance R1 and this is our resistance R2, always remember that in series connection, this is the most important part. Okay, in series connection, current remains unchanged. What does it mean? That means if current is flowing through the circuit, the value of, suppose the value of current is I through the resistance R1, the current will be same across the resistance R2I. That means the current is unchanged. Now what is the changing parameter? The changing parameter is our voltage. Voltage changes in series connection. That means Across the R1 resistance, the voltage is V1, the voltage is different, and across the resistance R2, the voltage is V2. Means that the R1 is not R2 in this circuit. Now, this is the main fundamental of the series connection. Now, according to the picture, I am going to derive the equation or derive the equation for the equivalent resistance for the given circuit. Let's draw the circuit first. What is given over here? The circuit is like R1. This is my circuit, R2, and this is the resistance R3. This point or node is A, and this point is nothing but B. Now you say, which parameter is unchanged? Current is unchanged. Obviously, what is the changing parameter? The changing parameter is voltage V1. I am taking the voltage V1 across the resistance R1, voltage V2 across the resistance R2, and voltage V3 across the resistance R3. Then what is the total voltage for the circuit? Total voltage is nothing but the summation of the three voltage. From the conservation law of energy, or if you go for the Kirchhoff's voltage law, we know that the total voltage V, which is nothing but voltage drop across resistances V1 plus V2 plus V3. Now suppose we are taking the total current for the circuit, or the supply current is I. We are taking supply or total current as I, and equivalent resistance as Req. Better that I represent Req as Rab, as in your question the two terminal or the two node is A and B. So from that formula we can simply write V equal to I into equivalent resistance R suffix AB. V1 we can write from the Ohm's law. V1 is nothing but I into R1. V2 is nothing but from the Ohm's law. We can write I into R2, and V3 is nothing but I into R3. Always remember, as the current is an unchanged parameter for series connection, that is why the current is unchanged. Now we are taking common of the current I Rab, that is equal to I R1 plus R2 plus R3. Now I is cancelled out from the both side. So our required equation is Rab, which is nothing but R1 plus R2 plus R3. This is the derivation for the series connection.